I would like to invite Zoltán Micskei to the floor on trustworthy AI-based systems. Zoltán is an associate professor at the Department of Artificial Intelligence and Systems Engineering. He's the leader of the Critical Systems Research Group, and the research group develops new methods and tools to help engineers create more reliable software systems. Zoltán?
Thank you for the introduction. Okay. So I also welcome everyone. My pitch will be about artificial intelligence. Artificial intelligence is reshaping every aspect of our life. And as the member of the Critical Systems Research Group, we are more interested in that AI-based systems are introduced even in critical systems like in transportation, automotive and railway systems, in industrial control systems, CPS and IoT systems, and even in every aspects of the healthcare systems. And contrary to web application or mobile application or social media, if there is an error in these kind of systems, they have a catastrophic consequence either on the financial or in the safety side. So therefore, the trustworthiness of AI components and the AI methods we are integrating in these systems is crucial. And why are we talking about trustworthiness in an event about networking and European cause? Because if we look into all the documents the European Union Commission has produced, like the ethic guidelines for trustworthy AI, the European AI strategy, or the EU AI Act, there is one central concept. The European approach for artificial intelligence is trustworthy AI. You keep this concept keeps coming back in every document, in most of the calls. Trustworthiness is an important attribute, but if we look into more into this concept, you can see that it's a multi-dimensional aspect that covers a lot of disciplines and a lot of properties. So starting, for example, for fairness or bias-free, trustworthy AI application is lawful, ethical, human-centric, reliable, safe, robust, secure, privacy-aware, and you can keep on going and listing all the different aspects that are important if you really want to build an AI system which is trustworthy. Luckily, the competence of BME covers numerous dimensions of AI safety, starting from the natural sciences faculty to the social science economic parts, and also the other engineering faculties are contributing to these aspects. Today I'm showcasing some of the collaborating research groups at the Faculty of Electrical Engineering and Informatics, where we are working more on the technical aspects of AI, the trustworthy AI-based system, like safety, robustness, reliability, and so on and so on. Let's start with our research group. The Critical System Research Group was founded by Professor András Patacsa more than 30 years ago, and I'm leading this research group. And we are interested in developing more reliable system. For the introducing AI in critical systems and in systems engineering, we are really interested in how existing software and system engineering approaches, methods co-evolve with AI techniques. And we try to bring in our expertise on modeling, formal verification into AI-based systems. I'm just highlighting two recent research topics from our research group. The first one is neuro-symbolic reasoning, where we combine traditional statistical, probabilistic, unreliable AI metrics with formal techniques, logic reasoning. And in this way, you can increase the trust in the output of AI-based methods. We are developing our own tools, for example, a graph solver specifically for these kind of challenges. It's called Refiner. It's an open source tool you can look up. I'm included all the website of the research groups I'm talking about. You can look into the research group website for publication tools, projects, and all the materials. We can use these kind of tools and techniques, for example, to create and generate diverse models and tests for AI-based systems that will enhance their assessment procedures. The other topic I'm highlighting is trying to using how we can use qualitative modeling in AI-based systems. Again, if you want to reason or assess or verify an AI-based system is really hard because of the large input space and the large models we are using. And with qualitative reasoning, we can decrease it and we can have an unexplainable AI representation for those models, which are helpful in impact analysis and risk assessment. Moving to the next research group, which is CRISIS, the Cryptography and Systems Safety Laboratory led by Professor Levente Butyan. They are working on cutting-edge security topics. And again, just a few highlights how they are connecting to this trustworthy AI part. There are many ongoing research projects on securing the privacy of AI-based systems. For example, how can we detect that training data is poisoned or someone tries to extract the training data? Or more recently, how can we reason about the security of LLM-based systems? AI is not just used as something we evaluate, but AI techniques can enhance existing cybersecurity methods, for example, malware detection or security testing. And with the introductions of agent-based systems, a lot of new research challenges opens, for example, contribution scoring, or how can we decide if an agent-based system is working in a fair way. Of course, fairness is defined very domain-specifically. The next research group is the High-Speed Network Lab and the Cloud Application Research Group, who are focusing on providing reliable compute platforms for AI models. They have a large and huge experience in AI and cloud-native applications, and they are using the next generation 5G or 6G networks, cloud, and edge to provide a computing framework for AI-based applications, which are reliable, can be trusted, and are robust. For example, to provide efficient near data processing or privacy-aware data processing clusters for AI-based systems. Introducing AI and these next generation networks opens a lot of use cases previously unbelievable, like for example, the new use cases of extended reality application or bringing new advanced driver assistance systems with the help of 6G services. The research group is very active on developing demonstrations for extended reality application and 6G services. I invite you to look into their website. There are a lot of cool demos, YouTube videos, what they're achieving, like how you can control a vehicle from a different continent and use other high-speed and high-reliability options of 6G networks. Last but not least, the AI research group from our research department works on the foundational topics and methods for artificial intelligence. And I want to just highlight two very important recent topics, which is human-centered AI. So how can we move AI closer to the humans, and how can we collaborate as AI researchers with other disciplines like legal or ethical requirements? How can we create models which are explainable to subject matters, and how can, for example, medical professionals or lawyers understand what the AI-based systems is recommending or what decision it suggests? Another very active research area is federated learning, where we have multiple partners who are not necessarily trusting each other. They want to train together an AI model, but they do not want to share their data. For example, drug discovery, or in any sensitive, where you have any sensitive IP protected information. And federated multi-source learning can help to share these data without actually sharing your private IP protected data. And the research group and also the CRISIS research group is very active on the privacy aspects and the scalable aspects of federated learning. For example, using it in different healthcare applications. Altogether, all four research groups, we are very active in European research projects. We have a significant experience starting from FP4 actually. I just started to count how many projects we are actively involved in recent years, and at least 10 EU projects where we are participating. I want to highlight that we are active also in proposal writing, have decades of experience in leading work packages, so we are very much open to new collaborations. We are interested in numerous horizon calls, from health to digitalization, space, civil society, and even transportation or autonomous vehicles. But some of our projects are from different cores like EU Digital or Eureka. So if you have a good idea about from these cores, we are very much open for discussion. To summarize, I think Trustworthy AI is a core concept in the next framework, in the current and the next framework programs. So we are very much like to contribute and collaborate on these topics. All four research groups have a significant experience which can be all integrated to cover of multiple dimensions of Trustworthy AI, and we have an experience in preparing and executing European Horizon projects. If you are interested, if there is a short question, I'm really eager to answer it, or you can contact me or any leader of the research group. Thank you for your attention, and let's hope that we can collaborate on some of these topics.